I think we've got a reasonable idea of how this application works. In this section, we're going to begin working on our first big feature that we're going to add to this application. The first big thing that we're going to add in is something called caching. Caching is a very easy way to dramatically improve the read performance of an Express application that makes use of MongoDB. Now, caching can be used with any type of database, any type, but we're going to especially be focusing on caching with Mongo. To give you a good idea of what caching is for, I want to show you some details about what happens whenever we load this application inside of our browser. I'm going to open up my Chrome request log. So over here I've got the network tab selected, and I'm also going to filter by XHR requests. I'm then going to refresh the application, and let's take a look at what happens. So as you'll see, there are 3 requests that pop up here. The bottom one that says info right here is related to the React server that's actually running for us. So that's not really relevant right now. However, the other 2 are much more relevant. You'll see one right here called blogs. This is a list of all the different blogs that belong to the current user. You'll also see a second request here called current user. So this is another request that is made to figure out who the current user of the application is. Let's take a look at how these requests are made in a diagram format, and it'll give us a better idea of exactly what's going on behind the scenes when these 2 requests are issued to the back end. Okay, so here's our diagram. The first couple steps here aren't super important, but I listed them out just to be complete. So everything starts off when our browser first visits localhost 3000/blogs. The React app loads up in the browser. The React app decides to make a request to the backend to figure out who the current user is and also retrieve a list of blogs that belong to them. So the request is made. That request is received by our Express API. Express takes that incoming request, one for the current user and one for the list of blogs, and sends each request off to the respective route handlers inside of our application. Those route handlers see those incoming requests, and then they make use of our Mongoose library to reach out to MongoDB and retrieve some amount of information. So Mongoose reaches out to the Mongo database that we just created, fetches some amount of data, and returns it to the Express side of our application. The Express app then takes that data and sends it all the way back to the React app, where the React app then uses it in some fashion to render the page on the screen. Let's very quickly take a look at one of these request handlers that is used in this process. Inside of my code editor, I'm going to open up the routes blogroutes.js file. So here's that file. If you scroll down just a little bit, you'll find a request handler that says app.get API/blogs. And inside of here, you'll find the actual Mongoose query that is used to retrieve a list of blogs to show to the user. So the point here is that every single time someone refreshes the page inside of our application, we always are issuing 2 separate requests to our Mongo database. Now normally, that's not a very big deal. It's not a big deal to make 1 or 2 requests to Mongo anytime we refresh the page. However, I want to show you some considerations that go into that, because we could very easily get into a circumstance where making those repetitive queries every time the page is refreshed does turn into a big issue. All right, so let's look at a diagram here. All right, so I want to tell you a little bit about what goes on behind the scenes anytime Mongoose makes a query over to our Mongo database. Whenever we execute a Mongoose query, and that's like the line of code we were just looking at, right? This one right here. So whenever this is executed right here, that eventually sends a query to our running MongoDB database. MongoDB has something internally called an index. An index are matched up with an individual collection. And you'll recall that a collection is like a collection of individual records. So inside of our database right now, we have one collection of blogs and one collection of users. So let's imagine what happens when that query to retrieve a list of blogs that belong to a given user come in. The query arrives at MongoDB. The query is then sent to something called an index. This index right here is an efficient data structure for looking up sets of records inside of that collection. Indices are efficient because they allow us to not have to look at every single record inside the collection to figure out which one we're trying to find. Instead, the index might allow us to kind of directly beeline the record that we're looking for. So like rather than having to look at this record and see if it matches the query, and this one, 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 the index allows us to go directly to the record that we care about right here. Indices like this are what make MongoDB very quick. So whenever we have an index that is working properly, these lookups of records occur very quickly, and we don't really have to worry about any issues around performance. However, there's something to be aware of here. Whenever an index is created for a Mongo collection, an index targets an individual property that exists on these records. Now, to be clear, indices have a lot of flexibility about them, and we can tailor them to look at multiple fields together or to consider different properties. But in general, for the sake of discussion, let's just assume right now that every single collection we have only has an index for the ID property of a record. So let's then consider our blog post as we are saving them into our collection. Every blog post that we create has 3 different properties tied to it. It has an ID, a title, and some content. So because we have this index over here for specifically the ID property, that means that if we ever ask Mongo to give us a blog with a particular ID, this index can very easily go and find the correct blog post. So like maybe that one, or maybe this one over here. So anytime we ask for a blog post with a particular ID, that operation is very, very quick to execute. Now here's where things get a little bit more interesting. What happens if we issued a query where we asked for a blog post with a very specific title? So in this case, maybe we don't care so much about the ID of a post, and instead we want to find a blog post with a title. Well, if an index for the title property does not exist, then we don't enjoy any fast lookup of data inside of our collection. This index right here is only relevant for looking up IDs on records, and it's not used for any other property. So if we asked for a blog post with a specific title, Mongo would have to fall back to its default behavior, where it first looked at this blog, it would look at that title property and would say, okay, does this match the query? No? Okay, I'm going to go into the next one. Does this one match? No? Okay, next one, next one, next one, next one. That process is what we refer to as a full collection scan. A collection scan means that we have to look at every single record inside of a given collection, which is an extremely expensive operation, relatively, of course, relatively extremely expensive. So the takeaway here overall is that sometimes when we make a query over to Mongo, if we have an index ready that satisfies the query, that query will be executed very quickly. However, you and I can very easily write queries that don't match up with an index or don't have an index available. So in those situations, we would very easily run into big performance concerns around our application. Now there's 2 ways to solve this performance concern. The first way, and this might seem like the really easy way, is to add in an index for that given field. So we can have multiple indices for a given collection. We could have one index for the ID property of these blog posts, and we could have another one for the title property as well. So that would allow us to look up blog posts with a very specific title very quickly and very easily. That might seem like a really obvious thing to do. However, whenever we add indices to a collection, that has an impact on our ability to write to that collection performantly. In other words, for every additional collection that we add, every additional index that we add to a collection, it takes longer to write records into that collection. In addition, anytime we add in more indices, that consumes more disk space and more memory as well. Finally, we might be making queries inside of an application where we can't really figure out ahead of time what indices we need for it. So maybe we start making blog post records that have like 30 or 40 different properties tied to them. And we might have to always be looking for different combinations of these properties. And we can't really figure out ahead of time what indices we would need for that. So in all those situations, this whole idea of using indices to solve these performance problems kind of go out the window, and we have to figure out some different solution. Okay, so in this section, we laid out some of the big performance concerns when looking up data inside of MongoDB. We spoke about how by default, we usually get these indices that help speed up queries. However, sometimes these indices are not working in our favor, and the query might occur much more slowly than how we expect. So let's continue in the next section. We're going to talk about how we're going to solve this issue using caching inside of our application, and then we'll start working on implementing caching inside of our project. So I'll see you in just a minute.